A fire alarm notification appliance is an active fire protection component of a fire alarm system. A notification appliance may use audible, visible, or other stimuli to alert the occupants of a fire or other emergency condition requiring action. Audible appliances have been in use longer than any other method of notification. Most of today's appliances produce sound pressure levels between 45 and 120 decibels at 10 feet. Methods of notification. The primary function of the notification appliance is to alert persons at risk. Several methods are used and documented in industry specifications published by UL. Alerting methods include sound, audible signals, approximately 3 kHz, approximately 3100 Hz tone, high frequency, used in many current notification devices, 520 Hz, low frequency, used in newer notification devices, 45 decibels to 120 decibels weighted for human hearing. Higher decibels, in the 100 to 120 decibels range, were common with older fire alarm horns. Light, visible signals, 15 candelas to 1000 candelas. Candela output, 1 to 2 flashes per second. Coding. Coding refers to the pattern of tones a notification appliance sounds in and is controlled either by the panel or by setting jumpers or dip switches on the notification appliances. The majority of audible notification appliances installed prior to 1996 produced a steady sound for or evacuation. In general, no common standard at that time mandated any particular tone or pattern for audible fire alarm evacuation signals. While less common than a steady sound, differing signaling methods were used for the same purpose. These are named with respect to their distinctive structure and include march time, usually 120 pulses per minute but sometimes at 90 pulses or 20 pulses per minute, depending on the panel. High-low, 2 different tones that alternate. Slow whoop, slow rising sweep upwards in tone, among others. Today these methods are confined to applications intended to trigger a response other than evacuation alone. In 1996, the ANSI and the NFPA recommended a standard evacuation pattern to eliminate confusion. The pattern is uniform without regard to the sound used. This pattern, which is also used for smoke alarms, is named the temporal 3-alarm signal, often referred to as T3. ISO 8201 and ANSI, ASA S3.41 temporal pattern, and produces an interrupted 4-count, 3 half-second pulses, followed by a 1 1/2 second pause, repeated for a minimum of 180 seconds. CO, carbon monoxide, detectors are specified to use a similar pattern using 4 pulses of tone, often referred to as T4. Audibility. From NFPA 72. 2002 edition. 7.4.2.1*, to ensure that audible public mode signals are clearly heard, unless otherwise permitted by 7.4.2.2 through 7.4.2.5. They shall have a sound level at least 15 decibels. Decibel. Above the average ambient sound level, or 5 decibels above the maximum sound level, having a duration of at least 60 seconds, whichever is greater. Measured 1.5 meters, 5 feet, above the floor in the occupable area, using the A-weighted scale. dBA. Quote, visual signals. In 1970, Space Age Electronics introduced the first visual notification appliance, the AV32 light plate, which was installed over an existing horn, and V33 remote light. Meanwhile, in 1976, Wheelock introduced the first horn strobe notification appliances with its 700X series. The majority of visual signals throughout the 1970s and 1980s were white or red incandescent lights. In the 1980s, most new installations began to include visual signals, and more strobes started to appear. In the United States, the 1990 Americans with Disabilities Act, ADA, triggered changes in evacuation signaling methods to include the hearing impaired. Audible notification appliances would now have to include strobe lights with higher brightness intensity to alert the hearing impaired. This made incandescent lights inadequate for the purposes of the ADA. Many existing installations that did not include visual signals were retrofitted with strobe plates. These retrofit plates would allow for the easy installation of a strobe without replacing the audible signal. Later ADA codes also required that strobes be at least 15 candelas and have a flash rate of at least 60 flashes per minute. 1 flash per second. Companies such as Wheelock and Simplex discontinued their translucent strobes and replaced them with new, clear, high-intensity strobes. Today, strobe synchronization is often used to synchronize all strobes in a uniform flash pattern. This is to prevent individuals with photosensitive epilepsy from potentially experiencing seizures due to unsynchronized strobes. Voice evacuation. Voice evacuation systems, also called voice alarm systems, have become popular in most countries. Voice evacuation alarms typically are not as loud as horns or bells, although generally standards require the same minimum sound pressure levels, and usually sound in alarm tone, typically a slow whoop, code 3, or chime tone, although this depends on the country and particular application, and a voice message warning that an emergency has been reported and to evacuate the building, often also directing occupants to not use elevators. Voice evacuation systems can also be used by personnel to give specific live information and/or instructions over the alarm system using a built-in microphone, which provides a distinct advantage over horns or bells. The system can be standalone, i.e., using dedicated loudspeakers, which can also feature integrated strobe lights, or the system can accommodate public address system functionality. In 1973, the Auto Call Fire Alarm Company manufactured the first voice evacuation system. Voice evacuation in Europe. In Europe, voice evacuation systems are normally a mandatory requirement for rail and air transport terminals, high-rise buildings, schools, hospitals, and other large facilities. Voice systems for emergency use date back at least as far as the Second World War. Following the lead of companies like Avalon, Tannoy and Milbank Electronics, etc. In the 1980s, many other companies such as ASL, Application Solutions, Safety and Security Limited began producing voice evacuation systems. In the 1990s, voice evacuation started to become the standard for large facilities, and is still growing in popularity. The use, design, operation and installation of voice evacuation systems is governed in Europe by CENELEC European Committee for Electrotechnical Standardization N 60849 and in the UK by the British Standard BS 5839 Part 8, a system code of practice. This is joined by the European Harmonized Equipment Standards Family N54 and ISO 7240-16, 2007. Effectiveness. Initial research into the effectiveness of the various alerting methods is sparse. From 2005 to 2007, research sponsored by the NFPA focused on understanding the cause of a higher number of deaths seen in high-risk groups such as the elderly, those with hearing loss, and those who are intoxicated. Research findings suggest that a low-frequency, 520 Hz, square wave output is significantly more effective at waking high-risk individuals. More recent research suggests that strobe lights are not effective at waking sleeping adults with hearing loss and suggest that a different alarm tone is much more effective. Individuals in the hearing loss community are seeking changes to improved awakening methods. Effectiveness of low-frequency, 520 Hz sound. Further NFPA research demonstrated the heightened waking effectiveness of low-frequency, square-wave auditory signals that use 520 Hz, especially when used to wake people with mild to moderately severe hearing loss. Two separate studies were conducted, one for the hard of hearing and one for the alcohol-impaired, in order to compare the waking effectiveness of 520 Hz low-frequency square-wave devices and 3100 Hz pure-tone T3 sound devices. Under the testing conditions, a 520 Hz square-wave T3 sound woke up 92% of hard-of-hearing participants, making it the most effective. The 3100 Hz pure-tone T3 sound woke up 56% of participants. A summary of the study shows that the 520 Hz square-wave signal has at least 4 to 12 times more waking effectiveness than the current 3100 Hz signal. NFPA code implementation of low-frequency, 520 Hz sound. Effective January 1, 2014. Section 18.4.5.3 of the 2010 and later editions of NFPA 72 requires the low-frequency audible fire alarm signal in occupancy sleeping areas with a protected premises building. Fire alarm system. The Chapter 18 committee chose to apply the requirement to all sleeping areas, not just those where occupants have self-identified as having a hearing impairment. This was done intentionally for several reasons. In many cases, the applications impacted lodging spaces such as hotels, and many people may not know they have a hearing impairment. They may be alcohol impaired. The 520 Hz low-frequency signal is required in sleeping areas of the following buildings: hotels and motels, college and university dormitories, retirement or assisted living facilities without trained staff responsible for waking up patients, dwelling units within apartments and condominiums. According to NFPA 72-2010. Section 18.4.5.3*. Audible appliances provided for sleeping areas to awaken occupants shall produce a low-frequency alarm signal that complies with the following. Effective January 1, 2014. 1. The alarm signal shall be a square wave or provide equivalent awakening ability. 2. The wave shall have a fundamental frequency of 520 Hz plus or minus 10%. See also: fire protection, active fire protection, passive fire protection, fire alarm control panel, fire alarm pull station, fire drill, false alarm, fire alarm system, smoke detector. Further reading: National Fire Protection Code, Article 72. Underwriters Laboratories Alt 217. Single and multiple station smoke alarms. Underwriters Laboratories Alt 1971. Signaling devices for the hearing impaired. National Fire Protection Association. NFPA Study Press Release July 26, 2007. Effectiveness of audible and alternative non-audible alarms. Photosensitivity and Seizures Resource at the Epilepsy Foundation. Hearing Loss Association of America Press Release. Current smoke alarm unable to wake millions of hearing people. IMO, ISO 8201 Alarm Tone Table. Visual Alarm Technical Bulletin. http www.systemsensor.com. NUS. Files, sound files, 520 Hz tone low frequency. MP3.